Hello. What we're going to do today is we're going to do this is a little bit of a tutorial. What we're going to do today is to show how to calculate mortality given a baseline mortality rate and a mortality improvement factor table. And this will help my particular class do their quiz. So let's go ahead and get started here and do the usual. So this is the idea. The first problem we wish to tackle is I'm going to go ahead and expand this a little bit, not expand it, contract it, and extend it downward because the tables themselves eat up a lot of white space. So the first thing is, given a table of mortality values at 2010, we'd like to find the probability that a life age 53 in the year 2013 dies before reaching 54. So let's just take a look at how to solve this problem. First one. So the first one for problem one, well, we know that mortality in 53 in 2010, which I'm going to label Q53 to 10, can be found on the given table. So 53 at time 2010 is 0.003225. So that's 0.003225. And that's just the table. However, what we want is the same mortality for the same age in 2013. Well, what happens there is that from 2010 to 2013, mortality has had 1, 2, 3 years to improve. So we have to multiply it by the respective mortality factors. Mortality improvement factors. Well, I misspoke just a little bit. But what we want right here is the age 53 and the mortality improvement factors for 2011, 2012, and 2013. So I'll go ahead and select this so we can see. And those are the relevant numbers. So these are the mortality improvement numbers. Because remember, in 2013, mortality has had 3 years to improve. So this is going to be the current mortality times 1 minus the mortality improvement. And this is 2011, 2012, and 2013. So it's 1 minus the mortality improvement in 2011 times 1 minus the mortality improvement factor. Well, 1 minus that, 12, and then in 2013. Okay, so that number can be, calculated with, shouldn't be that hard. And I thought I had my calculator right here. Oh, yes, of course I do. So this first factor, it's 0.9876. 0.9876. 1 minus 0.0148, 0.9852, and then finally 1 minus 0.0168. So we multiply these three together. Oh, I screwed that up. That's why you should never calculate in public. So 0.9876 times 0.9852 times 0.9832 times 0.003225. And that gives us 0.003085, call it 2. So rounding down to 4 decimal points after our answer, therefore, is this. And I'll just round to there. All right, so that's the first question. Second question, tutorial question is, if we have a life age 51 in 2011, what's the probability that that life survives to 53? Now, in that case, the very first thing we should do is just, and this is a 2. Well, this means that the person who's 51 survives to 52, and then if they go from 52 to 53. But in terms of mortality, remember the 51-year-old is 51 in 2011, so it's -1 minus Q 51 2011, and 1 minus Q, they're now 52, but this is now gone 2 years, so it's 2012. Now let's write this out. Let's write this out in full actuarial notation, and then we'll put in the numbers. So remember, our baseline is 2010. Then it's going to be multiplied by the mortality factor for a 51-year-old 2011. So we've had 1 year to improve our mortality. And I just screwed that up big time. If you're aware, you can see how I screwed that up. That's, of course, what I wrote was total nonsense. It's 1 minus the mortality improvement factor for a 51-year-old in 2011. And we only need this one factor here. So that gets us to this. And then, well, once again, we're given the baseline 52, 2010. But we've had 2 years to improve mortality. So it's a 52-year-old 2011. And then multiplied by, and I'll give myself a little bit of room here. One minus mortality improvement factor 52, 2012. All right. So now let's look at the numbers we need. Well, we need the baseline numbers. So at 2051 at 2010 is 0.002905. Okay, now let's make sure I got that right, because I'm prone to forget. 2905. Now, the number we want has had 1 year to improve its mortality. So it's for, again, a 51-year-old. So it's 51-year-old, 1 year. So it's 0.0180, 0.0180. Okay. And then this is multiplied by the mortality for a 52-year-old, the baseline in 2010 is 0.003057. I can't remember a thing. 3057. All right. And that's multiplied by, and we've had 2 years to improve mortality for a 52-year-old. So we go to a 52-year-old, 0.0156 is a mortality improvement factor. And then we've had the 2012 for a 52-year-old, 2012.0181. And then, of course, we get this. So now let's just do the calculation. So it's 0.982. So we can see the mortality improvement there. So 1 minus 0.0156, 0.9844. And that was 1 minus 0.0181, 0.9819. Now I want to go ahead and do this so you can actually see the mortality improvement to see how that changes. So this number here, 0.002905 times 0.982. So that goes to 0.00285271. And then this one here, let's see what happens to that 0.0037 times 0.9844 times 0.9819. It's 0.003576.355. So you can see that's significant. So that number is that times 1 minus 0.0028571. And we get our answer. Now, I carried it out a little bit too far, but that's how you do the basic calculations for mortality improvement. Now you should be ready to do the quiz. Thanks for watching.